suggest them to go on the same route. Okay, so and this will be a generic approach, right? Not too into the details so that you could think and create a roadmap of your own, right? So first of all, let's start. Okay, I will list down some stuff, and then we can look at how to approach them, the roadmap, and how to create a roadmap as well, right? I will talk about all of that. Okay, so let's get started. And first of all, you would want to learn about fundamentals, right? And in software or in computer science in general, right? So let me just scroll down. In computer science in general, you would want to start with some fundamentals. Okay, fundamentals. And a lot of people just skim through this whole section, which is very detrimental when you might be working, let's say 5 years later on some project, then you might remember, okay, why am I not able to optimize my performance? Why is there issue with memory consumption is too high or something like that? For that scenario only, this fundamental is necessary, right? Okay, so let me list down some topics that you might want to get familiar with when you're getting started. First should be a programming language, right? Programming language. And I will later come to kind of steps that you can take to learn it quickly, right? You would not want to just keep on spending like 6 7 months just learning this stuff and not actually applying it somewhere, right? You would feel it would be really boring, and you are not doing a PhD right now in this, so I would suggest an approach, right? A practical approach with this and any other stuff, right? First would be a programming language. Ideally, you should pick up a typed language. If not, uh, after that, you can progress to any untyped language. Like typed language could be your C, Golang, right? C, Golang, or Java, or any other. I would prefer C, C or Go. They are simpler, much simpler. They don't have extra stuff like classes and all. You could always learn about those stuff, but I would suggest pick up something, some simple language that you can like start with and progress, right, in your journey as a developer using that specific language. You have to at least get familiar with all of the stuff. So, uh, like loops, variables, and if there are data types, right? Data types, primitive and primitive data types, and your complex data types, which could be struct, which could be a tuple, which could be an array, or some collections, right? Data types, or I could say structures. Okay, structures to be more precise. S- s- There might be some built-in algorithms, right? So, so these are the things that you might need to learn in a programming language, and don't spend too much time in all of this. Just maybe a couple of weeks, maybe a month or so, right? If you're starting. Once you are familiar with the programming language, I would highly suggest go into other type of fundamentals like operating systems, right? Operating systems. And you would want to know, right? You are running your program. So operating system will allocate resources for your program. So you have to learn about this. You learn a language, let's say Golang. You then learn operating system, and everything that I'm saying should be learned in a practical way. You don't just go, okay, RAM works like this, memory works like this, CPU works like this, scheduling, no, no, not like this. You have to look at use cases, applications, and other stuff for every concept. If you do not find any use case, do not learn it. Until you find any use case, do not learn it. Okay? So this is the approach that you are supposed to take in anything, right? Even in a programming language, you should learn why are loops used. Okay? You should know why are variables used and how they are used. Okay? So you have to always ask these questions. Now, moving on ahead to your next fundamental, which would be uh, computer architecture and Boolean algebra, all of that stuff. You don't need to go too deep into that, but I would highly suggest this book from NAND to Tetris, right? NAND to Tetris. It's an excellent book, right? Where they teach you from Boolean logic to building a computer, right? To building a computer and also running programs, writing OS for it, running programs, everything, right? If you have 1 year, you should, I feel, dedicate some time to this book, completing it end to end, right? It will give you a overall perspective, right? You don't even need to learn operating systems after that. You can just do some Google search. You will be able to understand what memory is, how is it managed, what is a process, right? Process and all of that. Okay. But let's say, and for this, there is a book called Operating System 3 Easy Pieces, which is, let me just show you. So, 3 Easy, sorry, 3 Easy Pieces. All right. So, I open this up and I have this beautiful uh, practical based concept book, right? Online format. Let's say I go to this processes tab, right? I have this everything. Okay. I have the concepts followed by your summary and questions which are utmost necessary to do. They have this homework, right? Program. They have given you a Python program and they will ask you to run, right? And let's say while you are running this, you uh, encounter a doubt. Okay, you don't seem some things don't seem to be working. Okay, uh, what you are supposed to do is you just go ahead, do a Google search, ask ChatGPT on what that specific thing is. You keep on diving down deeper until you understand that concept, and then you come back. It's not like, okay, I don't know Python, so I will just first learn Python, then come to this specific assignment. No, not like that. You have to learn while you are doing practical stuff. That's the fastest way and the most practical way, right? Or else you will get bored once you have learned a language. After that, let's say you go after learning Go, you are learning Python. Okay, you will do okay, this is a variable, this and that. You won't be able to learn any language. I have experience in over 7+ languages, and this is not something to say, but how I learned is I worked on projects. If I encounter something that I don't know, let's say this week I learned about unsafe Java, right? So I didn't know about that. Okay, so follow this approach: operating system, then your computer architecture, and then you come to your uh, networking and web fundamentals, right? You need to learn about what HTTP request is. Okay, and it's not like you are an app developer, you should not know about this. You should, irrespective of that, know about how networking works, how web works, because uh, a lot of applications that you build will be communicating through network in some form or other. Okay, so you will need to learn about this as well. So Moving ahead, so this is just the fundamentals part. And once you are, I would say, once you are done with your programming language, right, you follow and fork in this approach. So you are done learning something, let's say Go, right? You do this thing, you keep on learning further, other topics, and you start building or apply, I would say, apply. And your apply will break down into new branches, which will be you can do something like problem solving questions, advent of code. There's this beautiful set of questions that is published every year, advent of code, or lead code as well, right? Lead code, lead code. Okay. So, and after apply, you have this, or you can build stuff, or you can work on existing ones, existing projects. I will teach you on how to do that in a while, right? So also, I missed one topic here, which is data structures and algorithms. So make sure to have some basic understanding of data structures. And there's this beautiful website as Open Data Structures, right? OpenDataStructures.org. This will have almost everything. Let's say I open the pseudocode edition. So they have all of these data structures. You can maybe follow some tutorial and all. Just get a basic understanding on this. Don't don't skip this. This is kind of a foundation on anything. So in operating systems, you will find some data structures being used in other domains as well, right? So follow, learn data structures as well. Okay. So okay, now this two forked approach, learning and applying. So once you are done with your fundamentals, start reading research papers, right? Research papers. They teach you a lot. Then company engineering blogs, okay, or some other form of podcasts, blogs that people might be having on tech related stuff. Don't go, okay, this company offers this salary. No, not those sort of podcasts. Go into tech podcasts. There are conferences as well, videos recorded for those conferences, right? There is GoConf and other stuff as well. You can watch those. They teach you a lot in very small amount of time. Then you can, if you are diving into a specific domain, let's say web development. So you can learn about that, and this should be done in parallel, right? Building, working on stuff, and uh, your learning should be done in parallel. Let's say you have 6 hours each day, divide it into like 2 hours to 3 hours of learning and 3 hours of applying. Okay, it's very important, right? So once you get comfortable, let's say in couple of months you get comfortable with some language, you are once you are done with a language, right, learning, you then start with OS and web fundamentals and all, then you start applying as well, okay, uh, through various means you can build something and all. So uh, once you have this, let's say going on for 1 or 2 months, you can further, okay, there is one more branch. This is important one. So let's say you are 2 months into your coding journey, right? So what you're supposed to do is you have to showcase as well on social media, any social media. It could be Twitter, Facebook, LinkedIn. I'd suggest multiple places. If you build something, once you could stream it, or once it's completed, once that project's completed, you can just showcase it through actual demo on your on YouTube or some other websites. And it will be really helpful, right, for you to engage in a community. Someone else might see that specific project and may reach out to you, okay, and you might get job offers through this as well. Okay, so that's that. So okay, now learning part, I told you, you can learn through research papers, you can learn through tech conferences, maybe some some concepts you might to want uh, to diverge with, right? And yeah, don't don't deep dive into any specific domain from the start. Wait for at least 5 to 6 months and try everything. Try everything. Okay, try everything. What I mean is, you maybe take 1 or 2 months to brush up your fundamentals, right? After that, you pick up everything. Maybe do some stuff in that, like web. You do some stuff in Android mobile, right? And if you have that capital, or maybe if you are interested in embedded systems, embedded or low level programming, okay, low level. So everything, just try everything from the start. It might be tough to work on something, some of the stuff here, like the embedded and low level programming, but just if you get stuck, ask ChatGPT or maybe do Google. There's a lot of free stuff available online. If not, you can reach out to me, right? You can comment on this video, and I will respond back. Okay. So once up until 5 to 6 months, you have tried everything, right? And alongside that, I on the learning part is over, right? Not over as in you have to keep on learning as you build stuff, as you apply stuff. So let's go to this apply stuff. Right now, I told you about advent of code. You could lead code, you could use any kind of platform to solve problems. You could go into build route and existing projects, right? How to do that. So let's first come to your build. Okay, so build. So what are you going to build? So so this should be the approach. Let's say you learn a technology. Okay, like Merge stack. Okay, you don't spend too much time in this. Just maybe 1 or 2 week max on concepts. As soon as you learn this tech, make 2 or 3 projects, some dummy projects, right? Let's say like a website clone, or something else in whatever domain that you picked up. Learn 2 3 projects to get familiar with it, then branch out. Okay, so first, what you are supposed to do is, so this will be built plus on existing one, right? Work on the existing projects. So you branch out, you build some stuff on your own, of your own, right? And make sure that this is some niche, not too niche, maybe something you might think of. So couple of weeks ago, there was a problem, right? Where I had this issue of uploading files to Google Drive, and Google Drive was randomly removing files from some of the users. So what I did was I planned to, and I planned that, okay, I can build something regarding this. So I am in the process of building that specific tool which will sync your files across GitHub and let's say GitHub, Dropbox, and other file upload services, multiple file upload services. This is called replication, kind of. And this really helps, right? Let's say one is down, and this is you can distribute your files as well, right? So you can maybe uh, distribute 3 partitions on GitHub, Dropbox, and Google Drive, others on Outlook, and something like that. Out, Sorry, not Outlook, OneDrive, right? So this I product thought of. You have to think about cases, specific cases. Don't just go on building, showcasing Amazon clone or something like that. Even if you are building a shopping cart application, you have to build something. Let's say you are building a shopping cart for sunglasses. Yeah, so that's kind of a niche. You have to go into that route. Okay. And if you are having difficulty finding use cases, talk to your parents, talk to your colleagues, talk to someone from other domains, right? Someone might be a content writer, talk about some issues that they might have while writing. Then you can maybe build something on that, right? In the start, you might not know, okay, how to do that. But as soon as you get the idea, okay, I want to build this. I did not know on how file uploads worked behind the scenes. Okay, but I learned. Okay, by building only. So learn by building is learn by build. Okay, so this is really an important thing that you need to do. Not a lot of folks, what they do is they just read 2 pages of documentation and they just get too overwhelmed with a new tool or technology, and then they drop that stuff. You have to go deep. You have to go deep into a specific tool set. Okay. Now you have 2 3 projects. After that, you what you do is you start building your own. Plus, you fork an open source project. You do not start contributing from the beginning. Okay, you just fork any OS project. Okay, any OS project which has a great depth of files. Depth basically directory, too many files and all. What this will teach you is you will clone it, build it on your own, on your PC, laptop, whatever you have. You build it, you run it after building, and you start exploring code base and add features, right? And maybe if there are bugs, fix them or add features, right? And what if the code base is too large? A lot of folks complain about that. So just use a debugger, right? Debugger. And every language, almost everything has a debugger. C has your GDB. It's for GNU applications only, but mostly it's a C, C++. It works great with that. Node has your Chrome internals. So there are other debuggers as well. Um, a lot of IDEs provide debuggers of their own, like IntelliJ for Java and other stuff. So okay, so debugger, this is very important. When you are learning a language, okay, learn on how to debug it as well. Do not just go, okay, console.log or whatever print statement you are doing. You won't be able to reach. It's a good approach in the beginning, but once you learn about debugger, you will exactly learn on how where the code goes. Okay, you click on print. So okay, what is happening inside the print? So it will redirect you to somewhere else. So this is the better approach on understanding a code base. Just fork a project, run it, clone it, build it. Okay, and then attach a debugger and just follow normal steps, right? Let's say I want to debug this code base for this website. I build it, run it, and I just keep clicking on through a normal user journey. Okay, let's say I click on next and I click on up and all of that stuff. You can watch debuggers, you can watch your debugger and set breakpoints on them and see okay where that code is going. Now, the main purpose of using an existing project, right, is because most often than not, when you get hired, you will be working on existing projects. And if you don't have an understanding on how to read a code base, you will, or if maybe a new code base comes in, right, in a separate language, if you are moved on to a project, if you get a new project, new team, you will face difficulty in understanding. Okay, so this is a great approach on building your intuition on how to understand code base and do it for different languages. Once you are familiar with 1 or 2 language, you can browse across, maybe have a cheat sheet of that language, and you can browse across code base on okay, what is this word? You are using Rust, so you see crate somewhere. So what is a crate? So something like that. Okay, you can you just have a cheat sheet of that language. You browse that code base, and you will be able to understand at least starting with 5%. It's enough. You start adding feature to that. Maybe let's say a small feature, and you will really understand how that specific tool work, right? So that's on open source. Once you're comfortable with that specific project for like a month or so, right? You have to really work hard on that. Then you can start contributing. Actually, you can join office hours for that project and you can start contributing. Now let's talk about what you can build on your own, right? You have built 2 3 projects. You are doing something in parallel on reading other code bases. It will teach you different styles as well on how to code, how to program well using that specific language. Now, how to build stuff on your own and on the niche side, right? I gave you some example, but I would also suggest some projects which are really challenging, but they teach you a lot. So, building a virtual machine, building an Excel, right? Excel or spreadsheet, building a web server from scratch, right? Building a compiler. You might think, okay, why do I need to learn on how to build a compiler? No, it's not about exactly learn how compilers work. That's an added advantage, right? Uh, but what this will teach you is it will teach you on how to use anything. Let's say you are learning writing this in even JavaScript. Why not? Why not? Why not? This will help you explore JavaScript in depth when you learn on how to write a VM, how to write a spreadsheet. This is the best way, you can understand, okay, how a code base should be written through open source or existing projects. But when you build anything, any complex application, right, which requires a lot of components, and this is not tough, okay, this is time consuming. All of these are not tough, okay. There are a lot of online tutorials available. Maybe let's say there is a tutorial available in C on building how to build a virtual machine. You can copy that tutorial and you can exactly build that in JavaScript, or maybe add new features, right? Add new features. Okay, so follow this approach, and once you are in like 6 to 7 months, and you are or doing all of that stuff, you are doing open source, you are learning stuff on your side, and you are doing projects. Okay, you are doing projects. Showcase everything. And by this point of time, you should have tried everything, every domain that you can think of: mobile, Android, or Android, no, sorry, web dev, desktop application, app, anything else. So by this point of time, you might have figured out, okay, I need to pick up this. But up until your 2 years of experience, right, do not specialize. Okay, and you have a lot of time. If you have 6 to 8 hours per day lying around, you can just spend like 2 hours maybe in learning things, which or maybe and 1.5 hours in DSA, right? If you want to prepare for your interviews, and other, I would say 4 to 5 hours in building stuff. And the time spent building stuff should be the greatest, because while you are building, it's not just you are just building things and you know everything. You will encounter a problem, you will do a Google search, you will do chat GPT, and you will learn as well in that process. So building time should be the most. Weekends try to spend like 10 hours on just building. It will help out a lot. So follow this approach at least for 6 months. And if you have any doubts on the resources, drop them in comments, and I will see you in next video. Goodbye.